Okay, so it's 10:03 on the Pacific West Coast in California. So we're going to start the community call. My name is Albert Wong. I am the developer advocate here at StarRocks Seller Data. As you know, we kind of have two names, right? A year ago, we donated the code and the trademarks of StarRocks to the Linux Foundation. As a result, we cannot use the name StarRocks for our own company anymore. So the company got rebranded to Seller Data, right? The StarRocks project is still the same, and it's part of Linux Foundation and so forth. So today we're going to talk a little bit about what's new with StarRocks 3.0. We're also going to talk a little bit about what we've been working around in the ecosystem. And we also have some asks of the community. For today's session, we are joined by Sida. Sida is one of the employees here at Seller Data, and he's in charge of product marketing. So Sida, why don't you introduce yourself and talk a little bit about what's new with StarRocks 3.0?
Hey, hey guys, thanks Albert. And hey everyone, I am Sida Shen. I'm a product marketer / product manager here at Seller Data. And so let's go over we're gonna be talking about today. So here's the agenda. So first I'll briefly go over what is StarRocks, what StarRocks is, and what is it good at, right? And second, I'll dive into user-facing analytics and to show some of the features that you should be taking advantage of, right? Those are the features I think they're really beneficial, but I don't see a lot discussion in the Slack channel. And lastly, I'll pick 3 features out of the 3.0 release that happened recently, right? And so first, let's dive into StarRocks. So what it is, it's a high-performance real-time OLAP database. And the thing good about StarRocks is very fast, right? Especially for aggregated and join complex queries, OLAP-style queries, right? It really has that, the best in-class performance, and we're gonna go into that later. And with all that, it supports real-time mutable data directly on StarRock's own columnar storage, right? And because it's high performance, right? The execution, the query planning, the query execution are really efficient. You can use it directly as a query layer for your open data lake, right? Specifically for Hive, Icebery, Hudi, Delta Lake. Right, it supports those 4 table formats, and on the data lake, get class-leading performance as well, right? And with all that, has high concurrency support and supports massive amount of users sending queries to start at the same time, right? So to sum all that, it's really good for kind of interactive analytics, like dashboards and reports, and because it's high concurrency, right? Even supports user-facing analytics very well, right? And let's go into what user-facing analytics is. It's basically a process that provides data insights to the end user of your product or service, right? And this helps your users to make more informed decisions, data-driven decisions, and make them happier, increase their engagements and retention, right? Thus leading to more revenue, right? So what does user-facing analytics demand from OLAP database, right? Because users, their end users, there are a lot of them, right? And it's going to be a lot of queries sending in, so you need high concurrency, right? And because it's analytics, they're always looking for OLAP style queries with a lot of joins and a lot of aggregations, right? And so from here now, I'll highlight a few features that really makes StarRocks good for this specific scenario. And right, I'll share the slides later, right? I'll make it public. And so the first is on the flight join. This is not really a feature, right? So if there's one thing StarRocks I can count on, it's join performance, right? Its join performance is really deeply optimized. It's best in class, right? So every time before you want to build some sort of denormalization pipeline, especially if it's real time, right? That's expensive and like labor intensive work, right? You always try on the fly join first before you build your denormalizations. I bet like 80–90% of the time it just work out of the box should. If your scenario is really demanding, right? You can always add more StarRock instances. StarRock is MPP, so it's designed to scale out horizontally. And so you add more instances and you can scale your performance, right? So here is a small benchmark between StarRock and Trino. The reason I chose Trino is because like rarely any database, real-time databases, real-time OLAP databases that's drawing really well. And so I picked a query engine from the Lakehouse architecture or the Lakehouse space, right? And for TPC-DS, 1 TB, 1 terabyte, and StarRocks is around like 5.5 times faster than Trino. That's just showcase how optimized our drawing is, right? And
Sida, before we go on,
yes.
Maybe you should mention a little bit what's unique about TPC-DS, that data set versus other TPC data.
Yeah, so yeah, great point. Forgot about that. So TPC-DS is really your most complex kind of queries. And say TPC-DS, you think of those heavy ETL jobs. So where the data lake engines are really excel at, right? And the TPCH, you can think them as ad hoc queries, for your data scientists. And later on, we're going to show SSB, and that is more for like simpler multi-table. That's for like your interactive dashboards and your reports, right? So TPC-DS is the most complex, one of the more complex data sets and query sets out there, right?
Right, and in fact, I think TPC-DS, majority of the testing data is where you have to do joins. So there are no flat tables. There's no the idea that a lot of the benchmarks that you see on out there are all flat tables, right? Where they
especially for
denormalize everything to get the fastest performance, and that's where everybody benchmarks is like, oh, I'm great. I've got like everything's denormalized and it's very, very fast. And then when you start doing much more of the complex joins, then they can't use that data set anymore, right?
And doing denormalization is expensive. I mean, for batch, it's probably okay to use Spark, but if you go into like streaming denormalization and try to join 17 tables with a stream pre-processing tool, and that's a pain. That's definitely a huge pain. So always try on the fly drawing with StarRocks before you go into any denormalization pipeline, right? Okay, so the next feature I want to highlight is query cache. I really see this feature used, but it's really powerful. It's basically for your complex aggregated queries, high concurrency aggregated queries, right? So it's actually not a final result cache. It's an intermediate result cache that's cached in memory instead of on disk. It's in memory, and it's actually the result of each node's first local aggregation, and it works for your aggregated queries and your joins. So it supports all of the aggregated operators, as well as your broadcast joins and your co-located joins, right? Accelerate those. So what's good about intermediate result cache is the cache hit rate is very high. So it works. It can use previous results even if your SQL is not identical and your scan data is not identical, right? As long as they are this, you guys can go into the documentation and search for query cache and read about what query works. So basically there is a semantic equivalent, or the scan data has overlap partitions, or the data ingestion is append only, right? All of these cases works. And so it's just to keep in mind that intermediate result cache, so our query cache does not actually replace a final result cache. So for final result cache, you want to, it works for like point queries or like unaggregated queries. And for StarRocks query cache, it works best, or it actually only works for aggregated queries, right? Just because it's intermediate result cache, it's still some computation left, but it does accelerate the query significantly. So this is the SSB 100 gigabyte single table. That's a flattened one. And you can see around 1 to 9, 10 times performance gain. And you move into the multi-table SSB. So the original SSB benchmark test, you see around 3 to that's 17 times performance gain, right? Yeah, so that's query cache. Go search it in the documentation and right, give it a try. Right?
Yeah, so Sida, is query cache enabled by default?
Nope. This parameter is set in FE and it's not on by default yet.
Yeah, so for all the community members that are on out there, if you like the performance of StarRocks just out of the box, you probably can turn on query cache and get even better.
That's free performance. that's yeah. If you have a lot of queries, the high concurrency OLAP style queries for user facing, and this is just free performance again with a little overhead of the memory. I think the default is like 2 gigs. Okay.
Right. Now, are there any other penalties for using query cache?
It might introduce a little like performance degrade on some queries because query cache still needs some planning, right? It's in the planning phase. It might have a little overhead, but not that much. It's not really that noticeable.
Right. So I mean, if you're going to execute queries over and over, query cache will definitely help you, right? If you do a lot of one-time ad hoc type queries, you might not get that performance gain. It depends on the intermediate, right?
Yeah, if you say you serve a dashboard, right? So it's fixed schema, like the query looks similar, but the parameters are different. This is where query cache shines, right? So the query script itself is not 100% the same, but like the predicates are different, right? Or the scan partitions are different, or there's data ingestion involved, or the SQLs are written differently. Oh, that's yeah. So yeah, so each of the cases, it still works. So that's free performance. Yeah. So the next is real-time pre-aggregation, right? This is a feature that's released a long time ago. It's been with StarRocks along the way, the last 2-3 years, and rarely see, not that many people use it, right? So this pre-aggregation is where you use it is for those extreme cases where the concurrency is very high. Even doing on-the-fly aggregation with StarRocks doesn't even work. So that's for your like absolute like in the high hundreds of QPS, right? And so we have 2 features for this. So first is synchronous materialized view, and the second one is aggregate table, right? And both of them are synchronous. So which means that the update, the refresh happens synchronously at data ingestion, right? So with each data ingestion, the pre-aggregation changes, right? So how to support real time, right? So the update or the refresh is actually incremental. So it's not dependent on how much data you have in the table. It's only dependent on the amount of data that's new or ingested, right? So the overhead is very low. That's how our real-time pre-aggregation can do real time, works in a real-time scenario, right? And also the materialized view supports query rewrite. And so you don't need to change your SQL script to actually benefit from it. So the thing is that all of these only works for a single table. This is for aggregation only, right? So pre-aggregation only. So when you want to, decide which one to use, the only big difference, the only factor should be, if you want to keep your raw data, right? So if you do want to keep your raw data, you can use a duplicated key table and create some synchronous materialized view. If you don't, you can just use an aggregated key table, and there's that. So save storage space.
Yeah. Do you have any other scenarios that you can think of that would be great for using this feature, right?
Like more like fixed schema, but the concurrency is very high, like for really those customer facing to see kind of scenario, right? you need really high QPS, and this works wonderfully.
So that's maybe like ad bidding, maybe some Web3 scenarios where you're tracking various digital assets, things of that nature, right?
Yeah.
Like
yeah.
the price of Bitcoin right now, right?
Okay. So that's all for the user-facing features. Let's go back to our topic 3.0, right? From here, I'll highlight 3 features from the 3.0 release recently. And first is the shared data mode. And this is huge because there's actually storage and compute separation, right? We all know what B is, right? B in the 2.0 phase, the not shared data modes phase. B is actually we persist your data on the B nodes, right? In your local disk, like for the public cloud for AWS is your EBS, right? Or your NVMe SSD, right? And in the shared data mode, we actually persist, the data is persisted in a external storage volume. That can be either HDFS or an S3 compatible object storage. And the immediate benefit of that is because B doesn't persist data anymore, right? So you can just drop a B node without really doing any decommission. It does not need to transfer the data out. So it really gives that elasticity that's really going to be very beneficial on the cloud, right? So when you don't use it, just turn it off, right? Without incur any more cost, right? And the second benefit of this is the storage cost. So object storage is much cheaper than your NVMe SSD or your cloud storage, right? Attached to your instance. And plus, like object storage has a really high availability, right? So we only need to keep one single replication persistent. So that contributes to this as well, right? So by our like rough calculation, this really can contribute like 80 to 90% of the storage cost, right? So cost saving.
So Sida, what about it? So if you don't need the disk anymore, where does cache get stored? Where do indexes
Yes, great
get
question.
stored?
Yeah, I actually missed that out. So, so B's local disk is actually used not for persistence, but it's for cache only now.
So materialized views, cache is still stored on a local disk. It's just much smaller, right? Because it's not.
Yes, it's not really smaller. It's disposable, right? Because it's not persistent on the local disk. It's only the cache. The cache can go anytime, right? The next time you boot up your BE, it's just a bit slower. The first code run is from S3 storage. It's a bit slower, but it doesn't really affect the safety of your data, right?
Right. So so just to be clear, there is still local disk.
Yeah, there's still local disk.
Local disk, but all the raw data is not stored on local disk, right?
Yeah.
We really treat the local disk as a cache. Right?
Yeah, we only treat the local disk as a cache. That's why you can throw away B node anytime you want without losing any data, right? And for performance as well, I forgot to mention it. So so if the local disk, B's local disk cache is filled, the performance is on par with 2.x. So, right. So when the cache is filled, the performance is the same. So, and yeah. And any more question for this one? No. Let's go to the next one. So this is asynchronous.
Oh, we got one other question that came on in. Actually, two. If we already have data on disk, how can we move it to the shared storage? So if you're already on non-shared architecture, how easy is it to move to the shared architecture?
That actually now you need to maybe like you have to re-ingest, right? So you need to have a another StarRocks cluster and do an insert into select, right?
Right. And then the next question we have is, how large do we need to set the BE local disk?
Okay, so it really depends, right? So ideally, you can set it as big as your data set. So that's gonna guarantee your, your max performance, right? Or you can set it very low to save cost, right? It's really depend on you, right?
All right.
While
Let's
ingesting,
see here. I've got some additional questions in regards to this 3.0 feature, but I will move that to the end of the
I see like 4. Okay.
I actually get a whole bunch of now people are asking questions, so
Yeah,
we'll ask them at the end.
Okay, let's go. Oh, sorry. How can I close? This is blocking me. Okay. So yeah, so the next one is asynchronous materialized view. So we remember we talked about a materialized view earlier, right? That's synchronous materialized view. That's for single table and for real time, kind of like pre-aggregation, right? And this materialized view actually we published it or released it quite long ago, actually 2.4, but the feature wasn't really that mature at the time, so we didn't really, market it that, advocated that heavily, right? But we've been iterating for almost half a year now, and I think this is pretty ready to go, right? So this materialized view, instead of, like for pure query acceleration, so this materialized view, you can use it for data transformation for your data warehouse layering, right? So instead of like, it's not real time, right? So it refreshes by your partition, right? So the refresh is kind of heavy, but the good thing is that it supports the full query syntax of StarRocks. So any select statement you can do with query, you can define them in the materialized view. So the good thing is that you can define all of your data transformation with a simple select statement, right? And it even supports external materialized view. So you can use a not materialized view. It even supports external catalog, right? You can even use a materialized view to kind of transform to ELT your data from your external data lake, like Apache Hive, right? And use that and bring it into StarRocks as a materialized view, right? And this is huge, right? And it supports join, supports aggregation, and it supports full query rewrite. So you do not need to change your SQL script to benefit from it, right?
Sida, can you actually build a materialized view with some of the data from local disk and some of the data from, say, for instance, Apache Iceberg?
Yes. And you can build the materialized view on top of materialized views too. So like this.
Very, very cool. Very cool, right? To be able to mix and match, like, so theoretically here, you can go and do as materialized views, even across like Hudi, Hive, Iceberg, and local disk, and do a join across all those different different types of external catalogs as one query, and we'll cache it, right?
Yeah, and we cache it. And okay, so after this, you probably should have some question because right, because to get the maximum query performance, right, StarRocks is like full in memory. So every query is executed in memory. There's no like stage by stage disk involved, right? Local disk involved, right? So it gets really fast query. It's good. It's okay for query, right? Where you can write a bunch of like predicates, right? So actually the data being processed is not that much. But for data transformation tasks, where there's no predicate, you try to join two big ass tables, it's gonna OM, right? So yeah, so in 3.0, we introduce operator spilling. So this is basically you spill your intermediate result to disk. So this actually ensures that your long-lasting queries do not OM. So according to the test now, at least we can do the full 1 terabyte TBCDS with only 64 memory, 64 gigs of memory, right? And this operator spilling supports sort, aggregation, and join, and that's basically all you need, right? And yeah, so this feature actually completes this.
Right. And not only it completes that, but if you're in situations where you don't have as much memory, or you want to say, for instance, your local, like a local on-prem installation or a disconnected, you want to embed StarRocks into an app, right? Or just a VM that's not that big in memory, you can still achieve that. You're just paying for is more disk and a slightly longer time.
Yeah, longer time and
to execute it.
Right. Like for your exploratory ad hoc queries and those TPCH style kind of big queries, when you have a small instance with that not that much memory, you can run them too now, right? But it's a preview feature, so use it with cautious.
Well, right. I would say that we highly encourage is GitHub issues, right? Like we don't know what we don't know, right? We try to do our best testing as much as we can. We try to write as much documentation as we can, but we really need to hear out from the community. So if you hit into an issue, right, chances are we're not aware of it. I mean, we're happy to fix it. We just don't know that it exists. So, send those bug reports in, send those asks on in, and then we can go and triage them.
Nice. Yeah, so that's actually all I have. You can take a screenshot. Those are all of the features you should try out, because that can make a difference. Those every single one of them can make a difference. And just to recap, draw on the fly, query cache, and single table materialized view aggregated table, and share data mode. Actually, this works with our Kubernetes operator, right? And you can give that a try. And operator spilling with batch transformation, the async MV, right? So what I want you guys to do is actually go into the documentation and search for those keywords. You're gonna find them and give them a try, right? If you'd like them, say in the Slack, so help other users to get started. If you don't, Slack channel, GitHub issue, or anything, right? I'll be there. We'll be there.
Right.
Okay,
well,
so
before we go on, let's ask those questions, right?
Oh yeah, you have.
Yeah. So first we have one from Rohan. It says, while ingesting using Streamload, how can I make sure that the data is persisted?
It's always persisted. If it's not persisted, it's gonna return fail. If it returns success, it's persisted. So with Streamload, we actually guarantees that with each transaction, all of data is either fail together or success together, right? So there's no like half-ass. It's transaction property. So yeah, and this works with shared data or the old 2.x architecture as well, right? Yeah. So the two are the same.
Next question. Do we have query response time benchmarks between 2x and 3x shared?
I don't believe we have anything public yet. We're gonna publish them, but I'm looking at the result now. So with cache filled, the performance is the same with 2.x. And with cache with no cache, just cold query, the performance is slightly faster with our external table, like Hive external table, right? With no cache as well. So next one.
All right. Next question. How much performance degradation is expected when querying from S3 with cache versus all from local disk or EBS?
See, this is a complicated question because it really depends on the profile of your query, right? So S3, from my experience, might be wrong. So the throughput is there. The throughput is really high, but it's just the response time is quite high. So it really depends on, like what is your data sorted, or, what kind of query you're writing. And there's a lot of factors, right?
Yeah, I think so, right, Sida? We have already some beta customers that are, or beta community users that are using the 3.0, right?
Yeah.
I mean, this was a feature that they requested to go up for us to go build, right?
Yeah.
Do you have any more data about some of their usage so far? Just to give the community an idea.
With the yeah, as I said, is with catch field is on par with the 2.x. So, and without it is on par with the Hive external table.
Yeah.
Basically, or external catalog table, right?
Next question. In the situation where local disk size is less than total size, can we configure the cache such that the most recent data is accessed from local disk, but older data will be fetched from S3?
Yeah. So there is an like a LRU mechanism that kicks out old data, and so with every ingest, so we actually view the ingested data as fresh data, right? So the newly ingested data always have the higher priority. It doesn't get kicked out that fast. So
it makes perfect sense, right? So that you keep the stuff that's hot, and then the stuff that's older will drop out of cache eventually.
yeah.
Next question. Can the materialized view table have longer data retention rule than the raw table on Iceberg?
Is that for, I'm assuming this is for the shared data cache, right? I don't think that's configured in there yet.
Yeah,
Sorry.
so why don't we follow on up on that? We'll take that and get back to you on that.
Okay.
So we got a question about documentation, right? I'll handle that one since I do a lot of the documentation. So as you guys can aware, this is an open source project, right? The documentation is always going to lag, right? And it's going to lag from a lot of different sources. So the best way for you to go and know what's going on is ask on Slack, right? That's the reality of it, right? Is that documentation is going to be best from the engineer. And as most engineers, I imagine, we're all engineers on this call, documentation typically gets the lowest priority of any single project.
Yeah.
All right. Next question. Why do you suggest us to use shared data mode with Kubernetes operator? Can we use it with the EC2 deployment mode?
Yeah, you definitely can. I mean, in Kubernetes, it's you get the elasticity, right? And with shared data mode, because you can kick the B node out of the cluster with no data loss, right? So it's really good for those elastic kind of workload, right? And that works with Kubernetes really well. And I didn't really I didn't mean to kind of recommended you only use with Kubernetes operator. It just works with the Kubernetes operator, and definitely yes, you can use it with EC2s, and you manage the elasticity yourself, right?
Yeah, I mean, I would add on to what Sida said, right? So, nice thing about containers is that it's ephemeral, right? That's one aspect. The other aspect too is a lot of the manual work of adding nodes, removing nodes out of the cluster, right? Getting it to work in terms of high availability and being able to do things like round robin, query execution, right? That's all automated in the kube operator. If you didn't have to go do that, if you didn't use a kube operator, you'd have to go and write scripts to basically add, remove nodes, shut down them cleanly, and all the round robin stuff, right? The layer 7 routing that has to happen between all the various nodes, right? So we automate that. Obviously, the kube operator could, just like the Linux binaries, could always be improved on. And so test out those scenarios and let us know, Like, let us know what you think about it and where are the gaps in both deployment patterns. Next question, what query acceleration capabilities are supported for external tables?
Yes, there is a data cache for external tables like your Hive, your data lakes, and that cache is actually for 3.0. It's not the same cache as the external as the shared data one, but it will be the same in future releases. I think in 3.1 or a smaller release in 3.1, right? If you turn that on, like according to our tests on the TPCDS benchmark test, it's only 12% slower than ingest, right? When the data is sorted. So in a kind of ideal situation, it's only like 10-12% slower. So actually, if you have data on your data lake, always try to turn on cache first and see the query performance. It probably be really good. It probably be good enough. Right?
Yeah, and I would also argue too is that if you look at the choices you have versus like external table versus external catalog, right? Like try to use the external catalog as much as you can, right?
Yeah.
And then in other situations, if that isn't available, then use external table. And in fact, we have a lot of community customers that ask the question about what's the fastest way for us to do data loading, and insert into from a external table to a local table is probably your fastest way of ingestion at scale, right? We're talking about billions and billions of rows from that standpoint. That's probably the fastest way for you to do it. So definitely, there's definitely preferences with connectivity to external systems. Next question, how do you ensure a query is not out of memory, especially concurrent required use cases? I think that's what you're saying, whoever is the anonymous attendee.
So try the operator spilling feature, and it's not on by default. Even it's on, you can have an option to do force spilling. So for each step is spilled. So that really doesn't use any memory, barely use any memory. So that will ensure your query that runs, and probably a bit slower, right? And in the future, we're working really hard to optimize this feature as operator spilling, and it's going to be a very important piece of StarRocks going on from now on. And we're looking to have it fully support the materialized view in the 3.1 release, and looking to have it default on into 3.2. That's the target, right? But for now, if you want the query to 100% success, turn on force spill. Just checking the documentation. It should be there.
Or ask in Slack, right? Documentation.
Yeah, ask Slack. Yeah, ask us on Slack.
It lags, right? And so, as you can imagine, the code moves faster than documentation. Even in my hearts of hearts, I wish we could just drop documentation. It's just like, look at the code, try it on out. But of course we can't do that. So we got to provide some documentation, right? The question becomes, is this balance of, the code velocity is so fast. I'm not sure if you guys track the amount of commits that are going on and changes, but we're in the thousands every single month. So it's very hard to go and keep the documentation up to date when we're in thousands.
Yeah, there's so much cool features we want to build.
Yeah, exactly, right.
Make your guys' life easier.
So let's go to the next slide, right? Because we can keep on going with questions, and I want to get on some of the other ones. So can we go to the next slide, Sida?
Oh yeah.
All right. So one of the big things we've been working on for the past couple of months is really around tested integrations, right? A better way for us to make it easier for you to, either get data from other systems or send data to other systems to complete the end-to-end use case for the requirements that you have, right? So just talking a little bit across the board here is that, we published a connector for Apache Flink. We also have is a beta right now of an Apache Kafka sync into StarRocks, right? Once we have that all flushed done out, that opens up things like debezium, right? For what we can go and do, right? And so that way you can do real-time CDC from whatever databases that debezium actually supports. Another big ask that we've had from other people here is supporting DBT, right? We've just initially gone down that path with some basic stuff, but people's asking for more. I would look out in the space. We need to find out, like, one of the big things here is that we're not quite sure how many people care about these integrations. So we need you guys to vote up the feature request on GitHub issues, right? And saying that I need this for this use case or whatnot, right? Because right now, a lot of it is just like, oh, we talked to some people, but it could be the data skew, right? We don't know if it's necessarily like 10 people want it, 20 people want it, or it's just this one person that just wants it and just is the loudest voice in channel, right? So I really do need you to help me vote on it. Another ask here was supporting large-scale ETL batch jobs, right? So that's working with, we have an initial connector with Airbyte. We're working on to make it much more scalable. Right now, it's a preliminary alpha for us to go and do it, right? Some other things that we did, we finally got the commits into Superset. So if you actually download Apache Superset and click on that little box that says what database it is, like StarRocks is listed there. So we made a dialect just for Superset, which is pretty cool from that standpoint. Tableau obviously is, so we did a survey with our community users about a month and a half ago, and they said that Superset was their largest like BI tool that they use. Tableau was number 2, so we've been doing a lot of Tableau testing from that standpoint. Metabase was also listed up there. Power BI was also listed up there, right? We actually even have is a Power BI connector that is more than the MySQL driver that you can go use, right? And Sida actually wrote an article last month about even using Excel and connecting Excel to StarRock so that you can just get data on out, right? So moving along, right? Some people have a lot of questions around our support for the data lakehouse, all the various table open formats that are on out there, right? I produced an article, just a quick matrix off of our tutorial page that talks about what operations we support on Iceberg and Hudi. So as of right now, most of it is read, but with 3.1, 3.2, ***, futures we don't necessarily know, but we're pretty sure. But we will have is write capability for Iceberg and for others. And so what that would allow you to go do is in the past cases, usually it's like, Apache Spark is writing it into S3 buckets for Iceberg, for instance. And then I'm using StarRocks purely as the query layer, right? By having us now write abilities, you don't need to use Spark anymore, right? You're able to just do inserts straight into StarRocks, and StarRocks will be configured to write that data on Iceberg using the Iceberg data for open table format onto an S3 or S3 compatible bucket, right? So there's some exciting stuff that's happening in that space. If you talk about in terms of usage from that standpoint, the surveys showed that that we probably have half of our users on Hive right now. and half of them are on Iceberg and Hudi, right? I think that's a general trend. What we see is a lot of people are not happy with Hadoop or Hive or in the performance, and they're moving data on out and putting into Iceberg and Hudi for all those additional benefits like that Iceberg and Hudi talks about, right? We definitely see the least is Delta Lake. And that I think is for a lot of variety of reasons. I shared those reasons, maybe not on a video, but definitely Delta Lake Trails by far is the least used among our community. Some of the other things that we've been working on, obviously we talked about the kube operator, that's been relatively new, and we've been working on it moving forward from that standpoint. We also have now some, not on the community, but actually enterprise users that are deploying on top of Red Hat OpenShift. And in fact, if you have time, next month in July, we will be speaking at a Red Hat meetup in San Diego. And we will be showing how StarRocks and Red Hat OpenShift is working together, and how you can have basically real-time analytics on a OpenShift cluster. And if you're not familiar with Red Hat OpenShift, it's basically Red Hat's version of GCP on-prem. So it comes with a software-defined network, it comes with software-defined storage, which is basically Ceph, and it has a Kubernetes environment that can deploy containers and VMs, right? So that's why it's like mini GCP that you can install in your own data center. And so we've been working to make that happen for some of our customers. All right, let's go to the next slide. All right, so I kind of mentioned this before, and I alluded to it, right? So, you know, the other, we've got people in the community who basically said like our tutorials could be better from that standpoint, right? And what we're trying to go figure on out is a little bit about documentation strategy. So documentation we can reference and much more static. We can publish it on docs.starrocks.io, but things that are much more fast moving, we wanted a better mechanism to go and publish that data and iterate the articles as fast as possible, instead of just like, you know, waiting for 2 months for us to make the perfect document. Is to make a document, at least you guys can get something, and then fast iterate that to the perfect, right? So you'll see a lot of work in progress, like WIP. I put this like acronym all over the place because there's still sections that are being written from that standpoint, but at least you guys have something and you know like what we're thinking about, right? So that we're storing it currently on GitHub, right? We might be moving to someplace else, but at least now it's on GitHub. And we have great articles there about like best practices of how to deploy StarRocks from that standpoint, where it also has examples of code of how we work with, you know, all the integrations that we work with, right? And also, you know, a lot of like documentation on frequently asked questions that we get on Slack, right? And so I would encourage you to go to those tutorials, right? Please vote them on up. That will tell me a little bit that you like articles that are like this. Comment on the articles to say like, I'm missing certain things, missing certain examples, or I need more explanation in certain areas, right? Obviously, it's an engineer writing to another engineer, right? But, you know, we all have, you know, different experiences. So I'm trying to write as for the general person that works in data engineering, but, you know, we could always make it better, right? And also we're open to what are some of the articles that we're missing from that standpoint. So someone asked me recently this week and says, I want to be able to have 0 downtime canary releases with StarRocks, right? So we lack some documentation in that area, right? So Albert, you know, could you work on stuff like that? And so, like, yet again, I put it as a work in progress. And so, I hear you, and we're trying to work towards that. Next one. So there's some other things I like from the community, right? So, some of the things that our committers have been asking about is like what do you want from an operator, right? So we'd love for you to take this survey and be able to tell us like these are the type of YAMLs, or these are the type of settings that I need to control from a operator standpoint, right? Tell us, right? It's hard for us to guess and hard for us to iterate, because yet again, we have a skewed perception of what is. Majority of the requirements that we get from the operator, to be very honest, comes from seller data, from the commercial enterprise arm of the company, right? But I would love to hear about from the community what they would be interested in, right? We also have another community survey that we want to go and do. And this is really to see about changes within our community itself. Like, say, for instance, like I mentioned, that half of our community was using Hive. With this newer survey, I'm curious if that has stayed the same or even dropped. And if you dropped, where did you go to? Did you go to Icebery? Did you go to the Hudi? Or I'm just staying within StarRocks itself because I like the new shared storage model, and that scratches enough of my itch, and I don't really need to go to an open table format, right? I'm curious, right? And so this gives us an idea of where to go and prioritize some of our time and investments in, right? Next slide. So we've got 3 more questions. We're almost 55 minutes into our session, so I'm going to answer these 3, and whatever questions else you have, you can always contact Sida and I off of community Slack. So first question, while ingesting from Kafka, can we configure storing the latest data, like 7 days, in cache and older data to move to cloud storage automatically?
Yes. So if the cache here you're referring to this shared data mode, the storage and compute separated mode, the cache for that, yes, and you can set a TTL for any the data you ingest. It's gonna get kicked out when the time is up.
All right. Will the operator spilling use the same local disk cache folder as the data cache in BE, or can we configure it to use a separate folder?
Great question. So actually you can, actually it's recommended you attach a different drive specifically for operator spilling, because it's going to use a lot of IO. The more IO you have, the faster the query is going to run. So the best practice right now is actually to attach another disk, separate disk specifically for the operator spilling, and you can right, that this way that doesn't affect your other services and get the best performance.
Yeah, it sounds like something with like NVMEs maybe for spilling, and you can use a slower IOPS disk for the caching.
Yeah.
All right. Then we have the last question for today is, can we use the debezium connector to ingest data into StarRocks?
That's so our routine load doesn't take debezium format yet, and so you would need to use StarRocks Flink connector. That's a debezium compatible, or we're developing a new Kafka connector, and that should come. I think the development is almost done, right?
Yeah, it's in beta right now, right?
It's in beta right now.
That's what I alluded to, is this Kafka sync, right? So then that will enable us to go with the debezium use case, right?
Yeah.
All right. Well, thank you everyone for taking time out of your day to join this community call. We appreciate it. So we like I mentioned, is that we're going to have future webinars from that standpoint, and maybe even and definitely some other community calls. look out on our calendar that we'll have on starrocks.io and also in Slack.
Yep.
Thanks again, and I'll see you online.
See ya.